What if I told you that some of the biggest ideas in math, ideas that the world's greatest minds were sure were true for centuries, were just wrong? But the history of math isn't a straight line. It's a messy human story, full of beautiful ideas that were so elegant they were just accepted as fact. Entire fields of study were built on them. But it only takes one exception to the rule, one clever counterexample, to bring the whole thing crashing down. Let's go back to the 17th century. Our first story is about Pierre de Fermat. You might know him from his famous last theorem, a puzzle that taunted mathematicians for over 350 years. But Fermat wasn't a professional mathematician. He was a lawyer who did math in his spare time, and he just so happened to be one of the greatest mathematical amateurs in history. Fermat was obsessed with prime numbers, those building blocks of the number system. He was hunting for a formula that would generate only primes, and he thought he found it. The formula was stunningly simple. Take 2, raise it to the power of 2 to the n, and add 1. These are now called Fermat numbers. Let's plug in a few values for n. If n equals 0, you get 3. That's a prime. If n equals 1, you get 5. Also prime. If n equals 2, you get 17. Still prime. If n equals 3, you get 257. Prime again. If n equals 4, you get 65,537. Fermat checked this one himself and confirmed it was prime. We have a simple formula, and the first 5 numbers it generates are all prime. You can feel the excitement, right? It really looks like he's found a prime number generating machine. Fermat was convinced. He wrote to a colleague stating as a fact that all Fermat numbers were prime. He admitted he didn't have a formal proof, but the pattern was just too good to be a coincidence. And for nearly 100 years, nobody could prove him wrong. The problem was the next number in the sequence, f5. It's 2 to the power of 32, which is a monster of a number, 4,294,967,297. In the 17th century, how could you possibly check if that's prime? The only way was trial division, testing prime after prime to see if it's a factor. The task was monumental, so the conjecture stood unchallenged, not because it was proven, but because it was too big to disprove. About 100 years later, the great Leonhard Euler came along. Euler was a titan, a man who loved a good puzzle, and he decided to take on f5. He knew brute force division was a fool's errand. He needed a shortcut, and he found one. Euler proved a brilliant theorem. Any factor of a Fermat number, fn, has to be in the form of k times 2 to the n plus 1 plus 1. For f5, this was a game changer. Any factor had to be of the form 64k plus 1. Instead of testing every prime, Euler only had to test numbers like 65, 129, 193, and so on. The search was still tedious, but now it was possible. He started plugging in values of k, and finally, for k equals 10, he tested the number 641. He performed the division and discovered that 4,294,967,297 is perfectly divisible by 641.
4 more conjectures that got proven wrong. Stay tuned for the upcoming long-form video.